Hello friends, myself Yash. In this video, we shall see a demo for memory forensics. So what is memory forensics all about? So basically memory forensics means dumping all the processes that are running in the memory and then analyzing them. This is very important because all the processes run actually on the memory or on the RAM. So if we take the dump directly from there and then analyze the same, we can get more concrete results. See, when we are doing malware analysis, when we try to figure out the actual steps taken by the malware, then there are multiple approaches for this. We can do a basic static analysis, basic dynamic analysis, wherein we use the string command, the UPX, the TEID, and for the basic dynamic analysis, we can use the process view or process explorer kind of things. And then we also have the advanced static analysis, wherein we can use tools like the OLIDBG and advanced dynamic analysis, wherein we use tools like the X32DBG and related, right? But in all those things, we are actually trying to analyze the main file that is present with us. We do not have the actual code present with us, but we have the exe file present with us. But when that file is actually running on the system and we directly take the entire dump from the memory and then we analyze the actual dump that is there in the memory, then we can get a much more clearer picture. Here, we are not analyzing one particular file. Here, we are analyzing the entire memory sample. We can tell, okay, and then this helps us find details in much more diverse way, and in we can actually get to know the exact like behavior of the malware. So this is a very important step, this memory forensics. Okay, for memory forensics, the actual process is something like we should ideally take the memory image of our system before running the malware, before having the malware in our system, for analyzing the malware, and then after having the backup and the memory image of the system, we should install the run the malware, and then we should take another image of our memory. We should capture the memory after the malware is present in our system, and then we should analyze that memory image. So we can use tools like this access data FTK imager. This is easily available online. FTK imager, you can register and get this tool. And if you download this tool, you can see this icon called capture memory. Okay, so if we click on this, we can see that our entire RAM will now be captured. Whatever is there present in our memory, whatever is there present on our RAM, will now be put into this file. This is a actual device, that is why it is MEM. If it is a virtual RAM, it will be VMEM. Okay, so we can get all the running processes details in this particular file, and then we can analyze this file, and it can help us know the actual behavior of the malware. So as this particular VM has around 3.5 GB of RAM, so it will be very slow if I take the like capture the memory of this VM now, and then we analyze that. So what we can do for demo purpose, there is a like a fairly available tool called Cridex malware. Okay, so you can download, you can search on Google Cridex malware GitHub, and you can get this link. And for this memory forensic, the actual analysis part that can be done using the volatility framework, which again can be downloaded from Google itself. So you can search for volatility framework and you can get this download link. Okay. So basically, we will use this volatility framework. It has many plugins. That is the biggest advantage why volatility framework is so famous for malware analysis. So it has many plugins, and we can use some of the most common like generally used plugins to analyze this particular memory sample. Okay, this is basically a 512 MB memory sample, 512 MB RAM image that has been taken on a like Windows XP machine, which had this Cridex malware running on it. Okay, so we will analyze this entire 512 MB of memory image, and we will try to see the like things which are not so like obvious, which might indicate that there might be a presence of a malware. Then we try to see the actual uh, like colors of the malware, the true colors of the malware. Okay, so volatility framework with its many plugins will be used for this, and as you can see, this technique helps us know better the ports that were in use, the number of processes running, the certain executables in the system, the connection details, and many more things. Okay, so let's start with the demo. So for this, we have this Windows 7 VM. Okay, which is around 4 GB of RAM. So this is the VMEM file that I have downloaded. It was a zip file. If you unzip it, this is a 512 MB memory file. Okay, so I'll just copy this file to keep things easier. And this is the volatility framework. This is also a zip file. If you unzip it, this is something we will get something like this. Okay, so I'll copy this cridex.vmem file over here on this folder so that it will be easier for us. And other thing which we can do is we have to run this particular command, okay, this particular application, volatility underscore 2.6 underscore win64 underscore standalone. This is pretty long, so I'll just make a copy of this and I'll just rename it to volatility to keep the things simpler. Okay, so this is the actual application which I'll be using for analysis, and this is the main memory image file over which the analysis would be done. Okay, clear enough at this point. So to start this, we'll go to CMD to start from here itself. Okay, so the first thing is to check the properties of this memory file. Okay, so what to the command will be volatility, okay, space, and then after that the command would look something like this: -f for the file name, and this is the name of the file, and then this is the command image info. Okay, so -f space, I just type cr cridex, no, not this one, not regis.txt, I want cridex.vmem space image info. This is the actual name of the command, image info. So see, this is just a factor in the memory sample, and over here also we can see that this process is actually a bit slow. So imagine if I had taken the complete dump of the 4 GB RAM, which I have on my VM, then how slow would have this things been? So it will take a lot of time. So it's always advisable that whenever we are doing such kind of analysis, to keep the RAM as low as possible, max to max 1 GB becomes one of it. So over here we can get some details like the suggested profiles. It looks like this is a Windows XP memory image, like what it's saying. The time 2012. Okay, it's a very old malware, but very good for demo purpose. Okay, so this is something about the memory image. So how to get more information about it? Okay, as I had said, we can get a lot of information. So we can use the multiple commands like ps list. Okay, process list. PS list means process list. So here we can see the processes that are running on this in this memory image. Okay, so Windows logon process is there, services.exe is there, SBC host is there multiple times. Okay, explorer.exe is there, and if you see these processes, okay, from a high level perspective, it looks like all things look normal. Uh, all of these processes typically run in any Windows system, but there are some things which look a bit suspicious, like this wuauclt.exe, alg.exe, reader underscore s1.exe, and spool sb.exe. So there are some processes which look a bit tricky. Okay, so we need to analyze them. Okay, so there are multiple commands. To first thing is identifying the processes which are running in the system. So there are multiple commands for that. One is ps list. Another famous command is psx view. This will give us the hidden processes as well. PS list we did. PSX view is there for the hidden processes. PST is same as PS list, just that it will list in a hierarchical structure. Okay, we can see the parent and parent and child processes also from there. So over here we can see that none of the processes are hidden. Like if you use PS list and PS scan, all the fields are true. That is, none of the processes are hidden. If it would have been false, that means a hidden process was running. So PSX view will also list the hidden processes. Okay. Another command which we saw over here was PSP. Okay. So here we can get a more parent-child type structure. Okay. So let's see that. See. So this is one process. This is sms.ls.txt is another process. winlogon.txt is another process. And inside this winlogon, we have services.txt and spool.sv and svc host and those kind of things. So this is the main tree structure. Okay, and here we can see that these processes which we had some doubt on. Okay, these are actually a part of the Windows logon.txt. So they might not be that suspicious. We can tell our doubt might not be very like we may need to analyze them, but we can keep it something towards the last. It may not be on the priority list, but something which is on the priority list is this one now, because this one is not like it looks something very standalone. It is directly running under process ID 1484, which is the explorer.txt. Okay, the Windows Explorer program. Okay, so this reader.s1 reader_s1.txt is directly running under this window explorer.exe, and this does not have any other child process as well, so this looks a bit suspicious. So let's have it on our list for now, and then let's explore some other commands as well that we can use on this memory image. So some other commands are conscan and sockets. So what is the meaning of this? So conscan will tell us all the active connections. Okay, so conscan, go here. Okay, so here what we can see that this process ID 1484, which is the explorer.exe, okay, this process ID is accessing these IP addresses. Okay, now what are these IP addresses all about? I have no idea. So for the time being, let us have a copy of this. I don't think I can copy that standalone. So let us do one thing. If we cannot, we can just make a note of these IP addresses. Okay, 172.128.41.168.5.145.125.19.103.198. Okay, so these are the IP addresses that are being used by this process ID 1484. Okay, now if this process ID is using them, that means either if the parent has something, the child also has the right to the access to that, right? So this process ID 1484 is using them. Along with that, all the child children who have 1484 as the parent, that means only this one, their S1_exe is also using these connections. Okay, we can tell. So this strengthens our doubt on this reader S_S1.exe, because these IP addresses are also being accessed by, can be accessed by this child process as well, because the parent is 1484 and the parent is accessing these connections. Okay, so this conscan was one command, useful command. Another useful command is sockets. Okay, if I give the sockets command, see, same here as well, right? Here also we can see the process ID and the addresses which are being referred to or which are being used. So I don't think there is anything extra which we can get to know from here. Everything looks fair enough for me. But if for this case, okay, so if we do not get anything from our present priority list, then we can try to figure out some suspicious process IDs from here as well. So one suspicious item can be this 1484 because the port number is 1038, and we know that the port number from 0 to 1024 is what is generally used, right? So 1038 and 1900, these things are not something which is very commonly used. So you can focus on these as well if you want to get any concrete result from our current priority list. Okay. So these were some commonly used commands, some commonly used plugins to be more technical. This Volatility Framework has different plugins. Socket is a plugin, Constant is a plugin, Mem PS3 is a plugin, PSX View is a plugin. So these are different plugins of this Volatility Framework. So now let's try to analyze the particular process which we have doubt on, which is this process 1640. Okay, so how to do that? So the best way or the most easy way of doing that is to first see the command line, like from where is this process running. Okay, so for that the proper command is, or the proper what we call CMD line we can tell. Okay, so from where is it actually running? So we can give this command instead of sockets is give CMD line. Then if I don't give the particular process ID, it will show me the detail of all the processes. Okay, if I just give the CMD line, we can see all the processes, all the PID. For all the PIDs, it will give me the command line location for that. But if I need for a particular process ID, say 1640, how do I give it? I give it space -p space 1640 process ID. Okay. So if I use the CMD line plugin, then I can get for this particular process ID, you can see we got only one result. Okay, so this is somewhat under other reader 9.0. Okay, again under reader. So I thought there is one, but I'm not sure why it's written over here like that. So maybe it doesn't look so like friendly. Let's see. Let's do some further analysis on this. So CMD line we found. Okay. Next useful command is DLL list, which will basically list down the DLLs. Now again, same process. If I do not give the, I think I do not specify the process, it will give me for all the processes. But I do not want all the processes for now. I just want to focus on one particular process. Okay. So here, see reader S1 looks like something related to a reader, right? But it is accessing the kernel. Doesn't seem good. It is accessing the network as well. NTDLL is for accessing the network as well. Again, looks suspicious. It is accessing the shell as well, which is again not so like what we can say, not something very usual. Okay, so this is actually strengthening our doubt on this particular process. So whenever we have like doubt on a particular process and we need actual proof, so what we can do is that we can take the dump of that process. First we take the dump of that process and then we see if the dump has something strange in it. Okay, so how to do that? And go to this Gmail and take the dump. The command, the plugin is proc dump. Okay, so I'll dump this process. EROC proc dump. The process ID is 1640. And where do I need to dump this process? So I'll dump it in this same folder only. So over here, I should see DMP file created over here if the syntax is right. Okay, some command, some spelling mistake, I think. Just copy this command. Okay, no such option. Okay, drop down. Okay, never see. Is it DUNP? Okay, it is POR. Okay, spelling mistake. Okay, sorry. DUNP drop down. Okay, is dot for this folder. So after this, a dump file should be present over here. Yeah. See, executable.1640.exe. This file has been dumped. Okay, so we can see this file is now present in this folder. So now what we can do, we can try to analyze this particular file. So the best way to analyze this small file or to scan this particular file is to use virus portal website. Okay, so if you can scan it using virus portal or any other website, then you can see it has actually something suspicious in it. So just try to check the hash. See over here. Now this clearly shows that this is a Trojan. Many antiviruses have identified it as a Trojan. So Trojan malware, Trojan, possible threat, Trojan malware. So meaning to say, as so many antiviruses have identified it as a Trojan, so yes, definitely this is actually a malicious file. Okay, so you can see the details as well. And yeah, this is the main. So you can see in our case, it is reading -day_s1.exe. Okay, so there are some other details for the same, and we can see it is using these DNS as well, which we saw, which was suspicious because it should not, the reader should not access the kernel. There is no need for the reader to access the kernel as such. So yes, even virus portal does confirm that this looks like this is actually a Trojan. Okay, so now we need to like get to know the exact details for this particular file. So once we have done with the process, so now we will, for this particular process, okay, now we will dump the entire memory image. This is only the process that we have done. That is why the size, as we can see, is only 29 KB. Now what we will do, instead of dumping the process, we will dump the memory for this particular PID, MEM dump. Okay, so this will, from this file memory RAM, this will take all the references of this 1640 process ID and it will dump it to this 1640.dmp, and then we can analyze this memory image, this memory file, to get more details. So see, now we have this around 73.6 MB file 1640.dmp. So now if we analyze this, then we can actually find the more details. So how to do that? So a very simple way of doing that is using the strings command. So first let's see if we can actually get something out of the strings command. So the command is simple strings 1640.plt. Okay, strings it will not find because strings is not present in this folder. So we'll just copy the strings function. Use the strings function. Just copy it over here. The strings file can be easily downloaded from the net, or we can use applications like bin text also. So now this one should run. Just pause it. Let's see if anything suspicious is here. Okay. Okay, till now everything looks good. Only thing is that robot. I am not robot, and I don't think anyone on this system is that name of robot. So this is something suspicious. Okay, so let's see if we can get more details. Otherwise, we will try to focus on this robot thing to know more details about it. Okay, so till now nothing else is there. So click on enter. It will continue. Again, right click to stop it. Nothing as such. It is accessing some errors. Okay. Again, I press space. Then I put a click to stop it. Nothing as such. Nothing as such. Space. Yes. Now we can see some things. Okay. Corporate accounts. Websterbank.com, onlineaccess.com, texascapitalbank.com, tdbank.com, pnc.com, suntrust.com. So now we can see the names of so many prominent banks as well. Okay, so this is definitely not something which should be present in any reader file. So here we can see that yes, this is actually a Trojan that is accessing many banking URLs. It has something related to the banking URLs, related to the banking domain, we can tell. Okay. So we can see so many banks are being accessed over here, right? See, so many banks are there. So many banks. Something it is related to do with the banking and is accessing the URLs of so many banks within it. So yes, definitely this is not a like genuine file. This is a malicious file. That's for sure. Another thing which we can like cross verify also is that when we were doing the initial analysis, we have seen some particular IP addresses. Okay, so we can see if this particular file, this mem dump file, okay, memory dump file has reference to these addresses, these IP addresses. So, like, is it interacting with them? Because initially we saw that the parent ID 1485, which is the explorer.exe, is connecting with those IP addresses. But if the parent is connecting, then also the child can connect from inside it, and we cannot see that. Okay, so now let's try to see if the child is actually connecting with this, so that we can see by analyzing this memory dump file, the 73.675. Okay, so I just stop it. See, we can see so many options. So it is doing this on those banking URLs, and it is doing something. It is even selecting some options, and definitely this is not something very good. So I just wait for it to complete. Okay, so yeah. No. So now this was a list of the IP addresses, okay, that I have seen. So I will try to find these IP addresses in this dump, okay, in this 1640.dump. This 1640.dnp is, sorry, not this one. Where is this? Yeah, this is actually this memory dump file, okay, that I have found, or we had downloaded, or we had extracted from the actual file memory of RAM. Okay, so how can we do that? The syntax for that is basically the same strings command, and then we have this grep space -fi, and then we need to like provide the IP addresses. So these are the three IP addresses that look suspicious. Okay, so we can just try one by one. Okay, this is not working. No issues. Just take this to the top, and then is 1640.dmp keyword space hyphen capital X small I, and the first IP address is something starting with 172.16. 172.16. Let's keep it in here itself. Let's see if we are able to find anything. Now this will search for this 172.16 string inside this entire dump file, and yes, we are able to find it. So basically, this is also actually accessing a particular IP addresses. It is still searching for that. When we had used the con scan and the sockets command, that time we were not able to see this particular process accessing these IP addresses, but now on analyzing the actual memory like dump of this particular process, we can see that yes, it is actually accessing these URLs and these IP addresses as well. So I'll stop it manually and I'll search for the other ones also, which is basically 41.168. 41.168. Let's see if it finds. This is also there. This is there the port number as well, right? So yes, definitely this is a malicious application, and this malicious application is accessing the banking URLs and it is trying to do something on those websites. So this is how memory forensics is actually done on systems. On live systems, we are expected to take the memory dump of our own RAM, and then we can do it. So for that, we can use tools like this FTK Imaging, and then we can get the dump of our own RAM, and then we can analyze that. And for demo purpose, we can use this like memory images which are available online, like this Cridex.vmem. So I hope this video was informative. Please do not try this technique on applications for which you do not have the permission. This is only for educational purpose. Hope you like this video. So thank you very much for watching.